Ask My Instructor 4.4.15. A small island is 3 miles from the nearest point P on the straight shoreline of a large lake. If a woman on the island can row a boat 3 miles per hour and walk 4 miles per hour, where should the boat be landed in order to arrive at a town 16 miles down the shore from P in the least amount of time? My recommendation is that you first draw a picture. The island is 3 miles from the shore. P is directly across from the island on the shore. The town is 16 miles from P. Let X be the distance from P along the shore that the boat lands. Then the square root of x squared plus 3 squared is the distance the woman rows. And 16 minus x is the distance the woman walks. How much time will it take? Recall, rate equals distance divided by time. Solve for time, and I get time equals distance divided by rate. Total time will be the distance rowed divided by the rowing rate plus the distance walked divided by the walking rate. The distance she rows is x squared plus 3 squared, the square root of that. The distance she walks is 16 minus x. The rowing rate is 3 miles an hour. The walking rate is 4 miles an hour. And so t of x gives the amount of time it will take for the woman to reach town if she lands x miles from point P. We want to minimize this function because this function gives the amount of time. Take the derivative of the function. We bring down the 1/2, and then it's x squared plus 9 to the negative 1/2 times the derivative of what's inside. The derivative of 16 minus x is just negative 1. Simplify that. Put the negative exponent down in the denominator. The 1/2 and the 2 cancel. And now let's change it back to radical notation. Once we have the derivative of the time function, we set it equal to 0. We could also ask ourselves where t prime does not exist, but you can see by looking at the function that t prime will exist everywhere because x squared plus 9 is always positive. setting t prime equal to 0, we see that we need a common denominator. We get our common denominator, and after we get our common denominator, we're ready to do the subtraction. We subtract and set it equal to 0. Now that we have a common denominator, we can see that the only time the left-hand side of the equation will be 0, we must have that numerator equal to 0. So what does it mean for that numerator to equal 0? If the numerator is equal to 0, what we want to do is find x. To do that, we isolate the radical. After we isolate the radical, we square both sides. And then we isolate x squared. We get that x squared equals 81 over 7. And so x equals plus or minus 9 divided by square root of 7. And we choose the positive square root because if you remember the picture, then negative square root would have her rowing away from town. We compare the time taken for x equals 0, and that would be the woman rows directly to shore. We compare x equals 0 to x equals 16, which would have the woman rowing directly to town, and compare that to x equals 9 over radical 7, which is that point in between. And we find that the time function is minimized at that point 9 divided by square root of 7. So the woman should land 9 divided by square root of 7 miles from point P if she wants to minimize time. That would be about 3.4 miles from point P. Okay, take care. Try this problem for yourself and let me know if you have any questions.